Bam, here we go. What are we doing on these 3 warm-ups? Adding and subtracting fractions. What's the kicker for adding and subtracting fractions? What do we call it? You remember? Common denominator. Yeah, buddy. Okay? All about that common denominator. Okay? In the first one, they're already common denominators, right? Okay? So when we first do that, we first find the common denominator, and then once we find the common denominator, then what do? Add the numerators together. So this would become up here, this would become 2 plus 4 on the top, and on the bottom, what's the bottom become? Just stays 9. Okay? It stays our common denominator. 2 plus 4 then is 6. So this becomes 6 over 9. And then what do I do at the very end? Reduce. They can both be divided by 3. So that gives me 2/3. I like 2/3 as my answer there. Whoa. Oh, now, oh, there it went. Look at that. That was phenomenal. It just popped right back where it needed to be. Love it. The sheet, yes. Did you get a book yesterday too? Yeah. Okay, good. Okay. Second one, are they in common denominator form? No. So first, I've got to adjust them into common denominator form. Now, what is the common denominator between 5ths and 6ths? 30ths. Okay. So 30 down there, right? Okay. And then now that I've got my common denominator, now I've got to adjust those fractions, right? So what times 5 gets me 30? 6. So I got to multiply 2 times 6 up there. Okay, because I need to get that to 30. Okay. What times 6 gets me 30? 5. So that means on this one, I've got to multiply the top by 5 to adjust that also. So then that gives me 12 over 30 plus 25 over 30. I can add the tops now. Top here would be 37. Bottom is going to be 30. And can that one be reduced? No. So we can either leave it like that. Actually, I would prefer 37 over 30. Or if you're a mixed up number kind of a person, you could also write it as 1 and 7/30. Okay? But math people prefer the improper fractions. Okay? So I prefer the 37 over 30 as opposed to the 1 and 7/30. Okay? Common denominator in the next one? I like 24. So the first one needed to be multiplied by 3. Second one needed to be multiplied by 8. Okay. So that gives me 21 24ths minus 8 24ths. So that would be 21 minus 8 over 24. What's 21 minus 8? 13? Okay. 13 over 24. Can that be reduced? Okay. Nor can it be written as a mixed up number. 604 in chapter 8. We're going to go back to the textbooks this chapter, just so you know. So we're going to be doing a lot of jumping around in your textbooks. Okay? So today we're going to go, oh snap! Look at the denominator on that rational. Okay? So, example number 2 here in problem number 1, it shows you how to do it if you were dealing with numbers, which is what we just did. We just did adding and subtracting of fractions with numbers. Okay? With me? You guys nailed it, knocked it out of the park. Okay? It's no different when you're dealing with rational functions. Adding and subtracting rational functions is the same as adding and subtracting numbers, okay, or regular fractions, if you will. Okay. First, you've got to. What did you do first? First, you got to find a common denominator. Now, the difference is when we were dealing with regular old fractions, the common denominator was a number. Right? In the first one it was 9, in the second one it was 30, in the third one it was 24. Okay? In a rational function, it might be numbers, like for instance up here in this example, right? It might be numbers, but it might also be something that you might have to factor, a polynomial of some sorts, okay? And we'll get more into that tomorrow, okay? But for today, it's probably just going to be numbers, okay? So, after we find that common denominator, what did we do next?
Multiply the numerator to multiply the denominator to get to the common one, and then you multiply that by the...
So we adjusted the fractions, right? To fit our common denominator. Yeah, okay. All right. Okay, so we adjust all of our fractions to fit our common denominator. Sometimes we might have to adjust all of them. Sometimes we might only have to adjust one of them. Okay, sometimes we might not have to adjust any of them. Okay. Then what did we do? Add or subtract what? The numerators. So we add or subtract the tops, and what happens to the bottoms? Stays common, right? And then what did we do last? If needed, we reduced it, right? I'm excited. You guys excited? I love this unit. This is math. We've been working for 6 months to get to this point right now, where we can finally do some cool math. All right? So, this is on page 605. Part A. Let's do part A together. Then I'm going to turn you loose on B and C. Okay? So, part A. First step was what? Common denominator. So, between 6, 4, and 8, what's the common denominator between those? 24. Love it. Okay? So, I'm going to have to make this plus, so we got 24 down there, and 24 down there, and 24 down there. Okay? So, step number 2. What do we have to do? We got to adjust, right? Okay? So, 6 times what gets me 24? 4. So that means I've got to multiply 3 by 4. 4 times what gets me 24? 6. So I got to multiply 5x by 6. 8 times what gets me 24? 3. So I've got to do, oops, I put it in the wrong spot. Wrong spot. So I've got to multiply y by 3. With me? Okay. So this becomes 12 over 24 plus 30x over 24 minus 3y over 24. So I've adjusted all of my fractions. Yes, huh? Okay. Now what do we do? Add or subtract the tops, right? Okay. So that's going to be 12 plus 30x minus 3y on top. And on the bottom, it's going to be 24. Okay. With me? Can I combine any like terms on the top? No, because they're all different, right? Can I factor anything out of the top? Factor a 3 out of the top, right? Oh, what's this? So if I factor a 3 out of the top, that leaves me with 4 plus 10x minus y all over 24. Yes? Can I do anything now? Can I divide the top by 3? And that makes this one go away, right? Right? Can I divide the bottom by 3? And that makes this what? 8. So my final answer here is, now how you write the top is how you write the top. As long as you've got all 3 distinct terms up there, I don't care what order it goes in, but that then is my answer.
Why can't you factor out the 4?
Factor out what 4?
The 4 on the top and the 8.
Because it's the 4 is attached to the plus 10x minus y. If I'm going to do it, if I'm going to simplify something from the top, it's got to come out of every single term. It can't just come out of 1. Okay? We call that the whack-off method. Okay? Don't do it. Okay? Okay? You try now B and C. First one, common denominator. 12. Do we all agree with 12? I like 12. Come on now, there it is. Okay, so what do I have to multiply the first part by? 4. So that means x minus 2y has to be multiplied by 4. Second one, what do I have to multiply that by? Nothing. That's already in common denominator form, so that one doesn't need any adjustment whatsoever. Okay. Third one, what does that one have to be multiplied by? Z times 3. Okay. So this becomes then 4x minus 8y all over 12 plus x over 12 minus 3z over 12. Yes? So then that becomes 4x minus 8y plus x minus 3z all over 12. So on top I get 5x minus 8y minus 3z all over 12. Anything factor out of the top? No. So that is my answer. Yes? A lot of people shaking their heads yes.
Wait, where did the 5 come?
Where'd the 5 come from? What's 4 plus 1? Right here.
Yeah, I didn't see that.
Yep. Okay. Common denominator in C. 18. First one, what do I have to multiply it by? 3. Second one, what do I have to multiply it by?
2.
Third one, what do I have to multiply it by? Nothing, more 1. Yep. Okay. So then this becomes 12x over 18 minus 4x over 18 minus x over 18. Okay, so my numerator then becomes 12x minus 4x minus x all over my common denominator of 18. So that one, 12 minus 4 is 8, minus 1 is 7. So I get 7x over 18. Nothing can be reduced. Okay? Questions? Comments? Concerns? Okay. When it's all said and done, all you're doing is adding and subtracting fractions. Okay? Handle? Awesome sauce.